Alright, so let's have a look at part 2 of this worksheet. So first of all, we have found in part 1 the volume of each of these shapes, and now in part 2 we're going to look for the total surface areas. For question A, we want to find the total surface area. So total surface area is exactly what it sounds like. It's the area, the total area of all the surfaces of the shape. So in this case we see this has 6 sides, right? So it's got a bottom part, it's got a top part, so that's already 2 of them. Then it's got the left hand side and the right hand side rectangles, so that rectangle and this rectangle, and then we still have the front and the back, right? So at the back, let's say that one is the back one, right? That's the back one. And then the front one, let's do that one in red. That'll be this one. Let me do that this case like this. That's the front part. Okay, so there we have all our different sides. Okay, so I'm gonna just clear that and then start coloring in again as we go along. So we want the total surface area. So I'm gonna say for number A, we want the front, we want the back area, we want the left hand side, or the left, we want the right. So these are all the rectangles in our shape, right? Okay, let me change colors for left and right. Let's do the left and the right. Left hand side, right hand side. We want the front and the back. The front, not the front and the back, I've already had that. We also want the top and the bottom. Top and the bottom. So those are all 6 sides of our cuboid. Okay, let me just write that front here. The front. Okay, so for the front, so let's say that's this part here. Okay, so the area of that. What is the area of that? Well, it's length times width, right? That's a rectangle. So length times width of the rectangle. So that's going to be 10 times 8. Okay, so that's going to be 10 times 8. Okay, so that gives us 80. Then for the back part, so in the back here, that's going to be this rectangle here at the back. So for that part, that's also 10 and 8, right? So that's also 10 times 8, and that gives us 80 as well. All right. Then next we're going to look at the left and the right. So the left hand side, this part here. Okay, so how do we find the area of that? Well, again, it's length times width. So our width here is 3, and our length is 8. So 3 times 8, or 8 times 3. Doesn't matter which way around. 8 times 3, 3 times 8, that gives us the same value of 24. And on the right hand side, same thing. It's width and length, so 8 and 3 again. 8 times 3, that gives us the area of the right hand rectangle. Now what we have left is the top and the bottom. So the top part, that's this rectangle here. Right, that rectangle. So again, this one, let me just color it in so we can see which one we're talking about. That one. So that's also 10 times 3, right? 10 times 3. Just draw that 3 again. So 10 times 3, that gives us the area of the top part. 10 times 3, and that's going to be 30. And for the bottom, that's going to be exactly the same. This rectangle here. Okay, so that's also 10 times 3. So 10 times 3. So you see, we just found the areas of each rectangle in our shape, of each of the outside parts. And now we just have to add them together. Okay, so here we have 80 plus 80, which is, so 80 plus 80, that gives us 160. 24 plus 24, that's 48. And here we have 30 plus 30, which is 60. And then we just add those together. So add all of them together. 160 plus 48 is 208, plus 60 is 268. Okay, so that is our total surface area for the first one. Now for the second one here, Okay, so we're going to have three surfaces here. I'm going to start with the top and the bottom. So let's start with the top. Or let's do here. We're going to do the top. We're going to do the bottom. Oops. The bottom. And what else is left in the cylinder? We also have the outside, the round part of the cylinder. Let's call it the outside, or let's call it the curved part. The curved part. Curved outside round part. Okay, let's start with the top. So the top, this is a circle, right? That's a circle. Okay, and it has a radius of 10, right? 10. Because we see that here in the bottom. So the top, that is, let me just write down, that's a circle. So that's going to be the area of the circle is pi times radius squared. So in our case, it's pi times 10 squared. And that gives us 100 pi. Okay, so that's the area of that top part. Good. Now let's find the area of the bottom part. So the bottom part is also a circle. Okay, so it's also a circle, that part there. And that also has a radius of 10, as you can see there. The bottom part, that's also a circle. And again, the formula for the area of a circle is pi radius squared. So in our case, that's pi times 10 squared. And that's going to give us 100 pi. So now we have the area of the bottom part. This part here. Okay, now for the curved part. Okay, so let's just do this. So if we imagine cutting this open straight down here. Imagine it's a paper cylinder. And you cut it open and then fold it flat. Right, so you cut it open here and then you unfold it, fold this whole thing flat. What will that look like? Well, let me do it like this. So if we fold it flat from there, it's going to look something like this. Right? Remember, we're cutting it open and folding it flat. So folding this part out there and this part out there. So that's what it's going to look like. Now, we see this is still 20, right? This length, that's still 20. But what about this whole length? What is that? Where does that come from? Well, that was this whole part here, right? That whole thing. So we cut open and fold it flat. So we can see this part, we folded it up to that edge, and this part here, we folded it out to that edge. So this whole part here, that's the top at the bottom. So, what is the length of that? What is that length? Well, that length, we know the circumference of a circle. So the circumference of a circle is 2 times pi times radius. So that is this, because this was the whole circumference of the circle, and now it is the length of the rectangle. So 2 pi r. That is this whole length here, 2 pi r. Okay, so the curved part, when we cut it open and fold it flat, it becomes a rectangle. So a rectangle, we just do length times width, or length times breadth. So the length of our rectangle is 2 pi radius. And our height is height, right? Okay, let's just do that. So in our case, 2 pi, our radius for this example was 10 for that circle. And then the height is 20. So times 20. Okay, so now we just multiply the numbers. So 2 times 10 is 20, 20 times 20 is 400, so we've got 400 times pi. 400 times pi. Good, and now we have all the three parts. We've got the top part here, we've got the bottom part here, and we've got the curved outside part shown here. Now we just add them all together, and that is the total surface area. So 100 pi plus another 100 pi is 200 pi, plus 400 pi will give us 600 pi. Okay, so 100 pi plus 100 pi plus 400 pi, that gives us 600 pi. Good. On to the next one. Okay, total surface area for this guy. Okay, so we're going to start with this left triangle here. Okay, so let's start with left triangle. Left triangle. Okay, so this left triangle, area for a triangle is half times the base of the triangle times the height of the triangle, the perpendicular height. I'm going to put that in again. Perpendicular height of the triangle. Okay, so in our case, that's half. It's perpendicular here because these make 90 degrees here. So that is, now in the test I will show you it's 90 degrees. There should have been a little 90 degree angle there to show, because we're not allowed to just assume that. Okay, so that they should show you that that is actually 90 degrees to show that they're perpendicular. The 6 and the 8 are perpendicular, so that makes us the base and the height, or base and the height. Doesn't matter which way around you put it. Right, you can decide it. You can rotate this image, put it down like you want. As long as the two sides of a triangle are perpendicular, that's the base and the perpendicular height that we need to use. So I'm going to use the base as 6 and the perpendicular height as 8. And then we get half times 6 is 3, 3 times 8 is 24. Okay, and that's going to be exactly the same for the right triangle here, the one on the right hand side. That's also 6 and that's also 8. Okay, so left triangle, I'm just going to write here right triangle. Same thing, half times base times height. So in our case, half times the base, which here is 6, and then the height, which is 8. Base, which is 6, and the height, which is 8. Half times 6 is 3, 3 times 8 is 24. Okay, so those are the two triangles. Now, let's get to the next part. The next, we still have 3 different rectangles to do. Okay, so let's start with the bottom rectangle. Okay, so this one here. That rectangle. Oops. Okay, so that rectangle, width of 6, length of 15. So let's call that the bottom rectangle. Bottom, so that's a rectangle. So we're going to say rectangle is length times width. In our case, that's going to be 15 times 6. Again, 15 times 6 gives us, so 10 times 6 is 60, 5 times 6 is 30, 60 plus 30 is 90. Alright, so that's the bottom part. Now, let's look at the next part we can look at. So let's say this back rectangle. So this back rectangle. Okay, so again, length is 15, right? And the height or the width is 8. The back rectangle, back, that's also a rectangle. So that is also length times width. And in our case, that's going to be length of 15 and a width of 8. Multiply those two together, and we get 120. Okay, now there's only one part left that we haven't looked at yet, and that part, what will we use for that? Let's use this. Okay, so that's going to be this part here, this rectangle. So let's call this the front one. Okay, this front rectangle. Okay, so the front rectangle, again, that's going to be length times width. Okay, in our case, the length is 15. Where did my mouse go? Okay, length is 15, and we need to find the width. Okay, the width here we don't know. So how can we find that? Well, we can use Pythagoras' theorem. So let's call this W for the width. So how do we find that? In a right angle triangle, the two short sides squared added together is equal to the hypotenuse squared. Okay, I'm going to just change color. It's difficult to see this here. I'm just going to do this as 6 squared plus 8 squared equals W squared over here. Okay, 6 squared is 36, 8 squared is 64. So this whole thing is 100. So 100 equals W squared. And then we take the square root of both sides, so we get 10 equals W. So that's 10. Alright, so that means in our triangle here, length 15, width 10. Okay, length 15, width 10. 15 times 10 is 150. And now we have all the individual sides, the areas of every part. Right? The left and the right triangle we did in green, those there. The bottom rectangle, the 6 times 15. The back rectangle, the 8 times 15. And we've got the front rectangle, the 10 times 15. Alright, now we just have to add all of them up. So 24 plus 24 is 48. Plus 90 is 138. Plus 120, that's 258. Plus 150, that is 408, I think. Let me just get a calculator to make sure I don't lie to you. Okay, so it's 24 plus 24 plus 90 plus 120 plus 150. And that's it, right? 408. Good. Okay, so that's the total surface area of this triangular prism. Next up, the last one of the picture ones. So first, it's again a triangular prism. Okay, so let's start again with the same left and right triangles we started before. So let's start with that triangle. The area for that triangle, let's call that left triangle. So that's going to be half times base times perpendicular height. Okay, the right triangle is going to be exactly the same. Half times base times perpendicular height. Alright, so if we take 24 as our base, we don't have a perpendicular height. That's a problem. So we need to get one. This will be a perpendicular line, right? Like that. So we need to find the value of that line. Right, how do we do that? Well, we see here these two are equal in length. So if we draw a line straight down, that's going to split this bottom part into two equal parts of 12 each. Okay, I'm just going to draw a slightly bigger triangle here, slightly bigger version of that one. So if we go straight down, maybe I should draw a slightly more accurate one as well, that looks a little bit more like an isosceles triangle. Okay, so we are told that is 15, this whole bottom part is 24, and since these are equal, both are 15, that means this bottom part is also split into two when we draw a perpendicular line down. So that makes this part 12 and this part 12. And we're looking for this perpendicular height. So again, let's just pick one side of the triangle. I'm going to pick the right hand side. That's a nice right angled triangle there. And now we find this height by using Pythagoras' theorem again. So that's going to be h squared plus 12 squared is equal to 15 squared. Okay, so h squared is equal to 15 squared minus 12 squared. So h squared is equal to 225 minus 144, that's 81. And then we get the square root of both sides. The square root of h squared is h, and the square root of 81 is 9. So 9 is the value of our perpendicular height here. All right? So now we have that. So we've got half times the base of our big triangle, which is 24, times the perpendicular height, which is 9. Same for this one. Half times the base of our triangle. Now I'm working that one, right? Base is 24, perpendicular height is 9. Perpendicular height is 9. So that works out to 12 times 9, which is 108, and the same here. Okay, so we've got our left and our right triangles. Good. Next, we will have our three rectangles again. Right, so let's start again with the bottom rectangle. So this rectangle here. So rectangle, let's do bottom rectangle. That's going to be length times width, and in our case that's going to be 50 times 24. Okay, 50 times 24, calculator. 50 times 24, 1,200. Okay, 1,200. So that's the bottom rectangle, this part here. Got that area now. Next up, what's the next rectangle we want to look at? Well, there are two more, so let's look at this back one. That one there. Okay, so again, that is 50 and that is 15. So the back rectangle, that's going to be length times width, which in our case means 50 times 15. So that gives us 50 times 15 is 750. All right, then we've got one more. That one's going to be exactly the same, right? This one, this front rectangle, right? That's the same. That's also 15 and 50. So the front rectangle, That's going to be length times width because it's a rectangle, and the length is 50 and the width is 15, which gives us 750. And again, that's all the different surfaces. We've got the bottom part here that we did in blue. We can still see the orange and the red ones we did, and in green we did the 2 triangle parts. So that is every part of our shape, and we just add all of those areas together. That gives us the total surface area. 108 plus 108, that's 216, plus 1,200, 1,416, and these two together is 1,500. So let's just add all of them up. 108 plus 108 plus 1,200, 1,200 plus 750 plus 750. So 2,196. 2,196. That is 2,916. My bad, I lied to you. 2,916. Okay, so that is the total surface area of this shape. Right, so you see, we just split it up into all its different shapes, and we find each one, add it all together. That's it. So there's nothing really funny here. It's just if you know how to find the area of a rectangle, a triangle, and a circle, then you can do any shape. Just split them up into those different shapes and find each area. Okay, question E. So a square-based pyramid with a side length of 5 and a height of 12. Okay, so they tell us the base is a square. So this time I'm not going to draw the whole shape. I'm going to say that's the base. They tell us that's the base. And this side length is 5. So that's a square with sides of 5. Just write them a little bit better so we can at least see what I'm writing. 5 and 5. So that's going to be the same at the top, right? Top and bottom. So let's call this bottom. That's the bottom. The top will look exactly the same. So the top will look exactly the same, also 5 and 5. Then we also have the left. So this is the top and the bottom of the prism, and then all around it's going to be all the same rectangles, right? So imagine this is front. Then we can do back. So the back is going to be the same thing. And the left and the right. Right, on the left it's going to look like this, and on the right it's going to look like this. Okay, so imagine, so with all these blocks are, so the front one it's standing right here on top of that, the back one is standing right on top of that part, the left one is standing on top of this part. So this left one, this is what you see when you look from this side, right? Front, that's what you see when you look from this side. And then the right is standing on top of that, so the right is what you see when you look from that side, etc. And then the top just goes on top of this whole thing. So hopefully that helps you a little bit imagine what's going on. So if we think about the front part, this length is 5, right? And we're told it has a height of 12, so the height is 12. Now the back, so we're looking at it from that side, so this length is 5, and then the height is 12. The left, so we're looking at it from this side, so this length is 5, and the height is 12. And the right, we're looking at it from this side, so this length is 5, and the height is 12. Okay, so we can just work out each face's area. So for this one, 5 times 5 is 25, 5 times 5 is 25, 5 times 12 is 60, 5 times 12 length times width is 60, length times width here, 5 times 12 is 60, and the same for this last one. And then we just add all of those together. 25 plus 25 is 50, 60 plus 60 plus 60 plus 60, so 4 60s is 240. We add 50 to that for the top and the bottom, and 240 plus 50 is 290. So that's our total surface area there. Alright, number F. A cylinder with a circumference of 12 pi and a height of 8. Okay, so circumference, so let me draw a circle here. Okay, and I'm going to copy that and paste so I have exactly the same top and bottom part. Something like that. And then just connect it with some lines. Okay, so there we have a cylinder. And we are told the circumference. So the circumference is this part all the way around, right? That length. The length of this line as we go around. That's the circumference. Okay, so the circumference of a circle has this formula. 2 times pi times radius. Okay. So, let's also think. Okay, so how will we do this? I'm going to do it like this. Right. I'm going to do it like that. Okay, so this that I just drew now, this is what we imagine if we cut open this circle, or this cylinder right here, and we fold it out flat. It's going to look like this, right? If you cut it open and unfold it, this is what it's going to look like. So we can see here, this length here, the circumference of the circle is going to be this length, right? If we fold it flat, that's this length is equal to this length. Okay, and with circumference we know is 2 times pi times radius. Okay, that's the circumference. Now the height, they tell us, is 12. No? Where are we? Height of 8. So they tell us the height of the cylinder is 8. Okay, so that's going to be the same height here, right? 8. Okay, so that's the curved area part. Curved area part, so how do we write the curved area part? Length times width, right? So 2 pi r times 8. So 2 pi r times 8. Okay, so 8 times 2 is 16. So we've got 16 pi r. So that's the area of this curved part, length times width. Now what else do we have? We've got 2 circles. Okay, so I'm just gonna do this. And let's change the color. Okay, so we've got 2 circles that we still have to work out. Top and bottom. So this one, okay, we don't know what the radius is, so we just call the radius r, right? Because that's the same what we did with here. So the not circumference, the area of this circle is going to be pi times radius squared. We don't know what the radius is, so that's all we have. Same for this one. Pi times radius squared. That's the area of that circle. So all 3 of these things together, the curved part plus the top plus the bottom, must be equal to oh, they tell us what the circumference is. Sorry, my bad. This is the kind of question we'll do in the next video. I misread the question. Let's start this one over. I apologize. Okay. We don't have to start the whole thing over. Just from here. Okay, so they tell us what the circumference is. So that's the formula for the circumference, 2 pi r. But they tell us the circumference is... Okay, they tell us the circumference is 12 pi. Okay, so the circumference is 12 pi. And that's equal to 2 pi r. Okay, I hope you're not lost. Circumference equals 2 pi r. That's the formula we know. And they tell us what the circumference is. They tell us in the question that it's 12 pi. So it is 12 pi. So 12 pi equals our formula. And then we can find out r from here. How do we do that? Well, just by, we want to get r by itself, so we can divide both sides by 2 pi. Divide by 2 pi. This will cancel out. So on the right hand side we just have an r left. And on the left, pi cancels out with pi. And 12 divided by 2 is 6. So that's the radius of our circle. Now that we know the radius of our circle, we can say the circumference is 2 times pi times the radius, and that gives us 12 pi. Okay, so that's 12 pi. Again, we're already told that in the question, so we don't have to figure it out again. That's just the circumference, 12 pi. But we'll need the radius when we do the areas of the circles. Okay, so the areas of the circles, we'll do this again, change the color. Okay, for the top and the bottom circle. So for the top circle, we have our radius now. Our radius is 6, right? We found that by just using the circumference formula. Okay, radius is 6. So the area for this circle is pi times radius squared. And that gives us 36 pi. Same here. Radius of this bottom circle is also 6. So that gives us an area of pi times radius squared, which gives us 36 pi. Alright, and the area of the curved part here is 12 pi times 8. 12 pi times 8. So that is, what is that, 96 pi. Okay, and now to find the total surface area, we just add the top circle, the bottom circle, and the outside curved part together. So 96 pi plus 36 pi plus 36 pi. So that gives us 168 pi. Let me just make sure. So 96 plus 36 plus 36, 168 pi. Okay, I just didn't type the pi's, but that's fine. So 168, oops, error. Let me just get back there. Restore file. Where were we? Here. Okay, so 168. Ooh, color has already changed. 168 pi. That's our total surface area. Bottom circle plus top circle plus the curved outside part. Those are the three parts of the cylinder. Question G, we don't have enough information to find the total surface area. Right? All we know is that this, so let me just show you what it could be, the different things. So it could be something that looks like this. Rectangular prism that looks like, a triangular prism that looks like that. Right? Or it could be something that looks like this. So we don't know what it looks like. And both of them could have the same total surface area. Right? You see these rectangles are much longer, the small bottom one is much less. So you see it can cancel out. We don't know the shape of the triangle. Don't know anything about the lengths, which lengths are how much. So we can't figure this out. We can find the volume because we know the area of this. So we know the area of this triangle is the same as the area of this triangle, but we don't know in what proportion the sides are. So we can't figure out number 5 here, number G. That's impossible. Okay, so that's it for this video, the total surface area of each of the shapes. Next, we will look at this, where one of the sides is missing, and we are asked to find it when given the volume or the total surface area. We have to find the value of a missing side. That'll be up in the next video. All right.